Every paved road, steel bridge, and concrete foundation we build relies on a hidden assumption that the Earth underneath will sit still. But the crust of our planet is in constant motion, and when it inevitably tears itself apart, our rigid designs fail instantly. In the Andes, tourists attempted to use a dry mountain shortcut. Within seconds, geological forces turned that static path into a weaponized flow of mud and rock. Even highly monitored spaces like aviation hubs are vulnerable. In the summer of 2024, a tornado formed directly over a Russian airport, tearing through radar systems and grounded planes to cause $2.4 million in damage. Human engineering represents a fragile negotiation with geological forces that can rewrite the physical rules at any moment. Urban infrastructure relies heavily on human operators. This creates a critical vulnerability known as a reaction time deficit. If a hazard appears faster than we can interpret the data, our safety systems are useless. A simple meteorological shift can bypass our planning entirely. In New Orleans, a sudden layer of thick fog dropped visibility to zero, nullifying traffic control systems and causing a 40-car pileup on a bridge. The margin between perceived safety and total destruction is often microscopic. In Italy, road workers noticed early signs of a collapse and ran. Mere seconds later, 350 cubic meters of earth and rock crushed the exact spot where they were standing. Advanced early warning radar is often outpaced by the sheer speed of atmospheric changes. An amateur storm chaser captured a new tornado spinning up and touching down before emergency broadcasts could even sound the alarm. This image of a silver Nissan in Colorado shows the immediate physical toll of a fast-onset hailstorm. If you look at this shattered rear window, you can see how suddenly falling ice bypassed human reaction time entirely, turning an expensive vehicle into an instant financial liability. This photograph from 2011 captures the eruption of Japan's Shimoedake volcano. This massive vertical ash plume erupted instantly, throwing a dense column of debris high into the atmosphere and forcing immediate, widespread flight cancellations. When safety relies on anticipating danger, abrupt environmental shifts turn our protective structures into inescapable traps. Beyond the speed of these events lies the question of mass, specifically how the weight and volume of water overpowers structural integrity. Take a look at this flooded street in Genoa, Italy. The tipped-over scooter and submerged sidewalks are the result of unrelenting continuous rainfall that mathematically overwhelmed the city's urban drainage systems, causing over $1 billion in damage. Here is a wide view of a flooded river in India from 2023. Homes built along these seemingly stable banks were quickly repurposed by nature as channels for massive kinetic energy, as the water displacement reached the base of the brick buildings. This Myanmar jade mine documents a catastrophic containment failure. The pit's depth against heavy machinery reveals immense mechanical pressure. Ultimately, fluid dynamics pushed water volume past the earthen wall's limits, rupturing the reservoir and sending a lethal cascade down the mountain. We saw the same unyielding fluid force at work in Meghalaya, India. Continuous rain swelled a river until the immense sustained pressure simply snapped the rigid steel tension of a heavy transit bridge. Flood control is largely an engineering myth. We merely redirect water until its mass exceeds our concrete thresholds, at which point our infrastructure itself becomes dangerous debris. Some disasters give us days or weeks of warning. But having the time to evacuate people does not give us the power to save our infrastructure. This photo shows 4 people standing helpless as the 2018 Hawaii eruption creeps toward their property. The lava flow moves at a walking pace, but its absolute thermal mass guarantees the total consumption of anything in its path. And this dark, icy street near the Boston Harbor illustrates a compound disaster. In 2018, rising water displaced into the streets, followed immediately by sub-zero temperatures that locked the frozen floodwater directly onto cars and buildings. Against fundamental physical properties, like creeping thermal mass or expansive freezing temperatures, humanity's technological tools are rendered entirely useless. These events are not isolated anomalies. The Earth operates as an interconnected system, meaning localized volatility often creates planetary ripple effects. A massive earthquake off Japan generates a tsunami, radiating immense kinetic energy across the Pacific. Striking a California port, this distant geological shift translates directly into a $26 million infrastructural disaster on the other side of the planet. From ash clouds grounding flights in Russia to this flipped white vehicle surrounded by hurricane debris in Uruguay, the evidence points in one direction. Rigid resistance to a dynamic environment eventually fails. Modern civilization must stop building with the illusion of mastering the Earth. Instead, we must design for resilience, acknowledging that we exist in the permanent collision zone of an untamed planet.